Hey guys, welcome back to Kleiba's YouTube channel. So today, let's talk about STEM implementations. So implementation of STEM comes with 5 principal steps. Step 1 being the consideration of the learning outcomes of the lead discipline, which could be science, maths, whatever. The second step is to craft authentic problems that are related to the learning outcomes. Problems can come from newspapers, current scientific research, or issues that the society may be concerned about. Step 3 is to build resources based on the problem. Consider the first thing that the task that students will engage in will be solving the problem. Second, what technology will be used in making sense of the problem and generation of the solution. And third, are there any mathematical learning outcomes? Next step, step 4, is to examine the connections between each discipline by thinking through the questions, by reading in between the lines and analyzing it themselves. And step 5 is to determine the classroom strategies to adopt for students to solve the problems. Some strategies include group discussion, peer critique, teacher consultations, visits to industries, etc. Now, when we talk about crafting an authentic world, that's a whole process that goes into it, and let's look at it. So first we ask, will the solutions to the problem require knowledge and skills from at least 2 disciplines? If the answer to that is no, we know it is not a complex problem. If the answer to that is yes, we move on. We ask, is the problem one that is widespread and has been around for a long time? If the answer to that is no, then we believe that it is not a persistent problem. But if the answer to that is yes, we move on and ask, does the problem require students to spend at least 3 to 5 hours to propose a solution? If the answer to that is no, then we believe it's not an extended problem. But if the answer to that is yes, we ask, how are the disciplines connected? What are the expected conceptual knowledge, epistemic practices, and social outcomes? That is what it takes to craft an authentic world. Now, talking about integrated STEM education, we first look at the nature and scope of integration. So we talk about type of STEM connections, we talk about disciplinary emphasis, duration, size, and complexity of initiative. Then we talk about implementation, which is basically instructional design, educator supports, adjustments to the learning environment. Now we look at the goals. So the goals for students with integrated STEM education would be STEM literacy, 21st century competencies, STEM workforce readiness, interest in management and making connections. And the goals for educators simultaneously would be increased STEM content knowledge and increased pedagogical content knowledge. Now we talk about the outcomes of integrated STEM education. So the outcomes for students are learning and achievement, 21st century competencies, STEM course taking, educational persistent and graduation rates, STEM related employment, STEM interest, development of a STEM identity, ability to make connections among STEM disciplines, and simultaneously we look at outcomes for educators, which is basically changes in practice and increased STEM content and pedagogical content knowledge, which is equally as important. So thank you for watching this video and we'll see you soon again. Bye bye.